Alrighty, I got my computer back, but that was because I had to replace the graphics card for whatever reason. It was not working anymore. But yeah, that was like a 2070 Super. So now I'm using a spare, and it's like my last spare graphics card, which is a 3060 Ti. I think this is like the same level in terms of performance, so I didn't really get an upgrade. Um, yeah, so let's continue from last time. I'm glad we did get some coding done, so that's good. Anyway, um, managing configuration options. An earlier section in this chapter looked at compiling the fishing pole module only if the config fishing pole configuration option was set. Configuration options have been discussed in earlier chapters too, but now let's look at actually adding a new one. Continuing with the fishing pole device driver example. Thanks to the new K build system in the 2.6 kernel, adding new configuration options is easy. All you have to do is add an entry to the kconfig file responsible for the applicable branch of the kernel source tree. For drivers, this is usually the directory in which the source lives. If the fishing pole driver lives in drivers char, you use drivers char kconfig. Okay? If you created a new subdirectory and want a new kconfig file to live there, you need to source it from an existing kconfig. You do this by adding a line such as the following to an existing kconfig file. Okay, so you will need to point your new kconfig file from the existing one. So you would add this to a more top level directory, and this will be the k. You'll have the kconfig inside the fishing directory here, and you'll just reference this kconfig file with this line inside this kconfig. We'll probably try that. So entries in kconfig are easy to add. Our fishing pole module will look like this. So config fishing pole. So this one will be our config option. Tri-state, I guess basically it means yes, no, or module. Yes being it's going to be statically compiled. No means you don't want to compile it at all. And module means it'll be dynamically loaded as a kernel module. So Fishmaster 3000 support, I guess that's the description. Default, no. Help. So this is the help text. If you say yes here, support for the Fishmaster 3000 with computer interface will be compiled into the kernel and accessible via a device node. You can also say M here, and the driver will be built as a module named fishing.ko. Okay. So if unsure, say no. Let's see. The first line defines what configuration option this entry represents. Note that the config prefix is assumed and not written. The second line states that this option is a tri-state, meaning that it can be built into the kernel, built as a module, or not built at all. To remove the option of building as a module, say if this option represented a feature and not a device driver, use the directive bool instead of tri-state, so yes, no only. The quoted text following the directive provides the name of this option in the various configuration utilities. The third line specifies a default for this option, which is not built. So Y or N. Weird. All right. You can also specify the default as built into the kernel. Okay, now that's Y. Or built as a module, M. For device drivers, the default is usually not to build it. So default, no, don't build it. The help directive signifies that the rest of the test indented as it is the help text for this entry. That the rest of the test indented as it is the help text. Okay, I think this meant to say text. The various configuration tools can display this text when requested. Because this text is for developers building their own kernels, it can be succinct and technical. End users do not typically build kernels, and if they did, they could presumably understand the configuration help. There are other options too. The depends directive specifies options that must be set before this option can be set. If the dependencies are not met, the options is disabled. For example, if you added the following directive to the kconfig entry, the device driver could not be enabled, yes or no, or yes or module, until the config fish tank option is enabled. Depends on fish tank. Okay, that's if we had another module that had a fish tank configuration option. The select directive is like depends, except that it forces the given option if our option is selected. The select directive should not be used as frequently as depends because it automatically enables other configuration options. So if you decide to compile the module and it has a select directive, any other options by that select directive will be set to be enabled too. So the following line enables the config bait whenever the config fishing pole is enabled. Select bait. For both select and depends, you can request multiple options via and. With depends, you can also specify that an option is not be enabled by prefixing the option with an exclamation mark. For example, depends on example drivers and no fishing allowed. Not no fishing allowed. What? With depends, you can also specify that an option not be enabled. Okay, that's a confusing name. That's what it says no fishing allowed and it has not. So not no fishing allowed. So no fishing allowed is, let's say it's true, not is false. That's confusing. Let's see. This line specifies that the driver depends on config example drivers being set and config no fishing allowed being unset. Oh, okay. Okay. Makes sense. So this will be false for this needing to be true. Sure. So no fishing allowed is false. That means fishing is allowed. So this will only be true if no fishing really is allowed. Okay. So the tri-state and bool options can be followed by the directive if, which makes the entire option conditional on another configuration option. If the condition is not met, the configuration option is not only disabled but also does not appear in the configuration utilities. For example, this directive instructs the configuration system to display an option only if config ocean is set. Here, deep sea mode is available only if config ocean is enabled. Bool deep sea mode if ocean. Okay. Deep sea mode is only available if config ocean is okay. Cool. Okay, so this is for just displaying only. So it's like that nested menu when we did the make menu config. So the if directive can also follow the default directive, enforcing the default only if the conditional is met. The configuration system exports several meta options to help make configuration easier. The option config embedded is enabled only if the user specified that they want to see options designed for disabling key features, presumably to save precious memory on embedded systems. The options config broken on SMP is used to specify a driver that is not SMP safe. Normally, this option is not set, forcing the user to explicitly acknowledge the brokenness. New drivers, of course, should not use this flag. The option config debug kernel enables the selection of debugging related options. Finally, the config experimental option is used to flag options that are experimental or otherwise of beta quality. The option defaults to off, again, forcing users to explicitly acknowledge the risk before they enable your driver. Okay. Okay, so I guess we can try to implement something like this. So what do we need here? Let's see, loading modules, configuration. We just need to modify this kconfig file to have this one here. We'll need to create a fishing kconfig. Okay. Sure. Let's just take it a step at a time. Let's see, dev. Oh. Forgot where all this lives now. Linux. Linux. Where did it go? Oh, Linux dev. Okay. Let's actually see if we still have our stuff. It's been a while. Okay, so okay, fishing. It's in fishing. So CD. Okay, we'll just do this. So then let's go to drivers, fishing. So what was this again? Okay, so we had all of this stuff. Okay. Wow, so many reds. It's okay. Okay, so this is our fishing module. Okay, so I remember this. So then we can do, was it drivers char k config? And so this is what it looks like. Are there any sources here? Yes, there are a lot of sources here. Driver serial. There's also drivers. We put in drivers what? Char. So drivers char fishing. Yeah. So we need kconfig inside this file. Right in here. So cool. So what do we do? Shall we just do then? Okay, %h. Oops, %h. What was it? Kconfig. Was that it? Kconfig. Okay. No range allowed. What does that mean? Oh, e%:h kconfig. Done. Okay. So should we just copy all this? Let's just copy all this. Let's just do this. We're gonna create a new config option called fishing. Okay. Ooh, that's okay. So we're gonna indent tri-state default help. Okay, so tri-state default help, and then this one will probably 2 times indent. So then we have this file, and then we need what drivers char kconfig, and we're just gonna have to go down here and let's source drivers char fishing kconfig here. Okay, what else do we need? I think that's it, right? So then if we were to oh, we need to also modify our makefile to take into consideration of the option. So is it here? Yeah, obj config fishing pole. So then we need to do that in our build system. Okay, so we also need to do the drivers char makefile. We need to modify this, and then we also need to modify it in the fishing. Okay, let's just see. All right, so we need to modify the makefile in drivers char. So we do that, drivers char makefile, and then this, it should be what, fishing? Oh, right there. Okay, so now is it like this, config fishing pole? Okay, and then if we were to go to our fishing makefile, we should also do the same here. So because that's how it can read the configuration file, whether or not it needs to compile the fishing source files. So with the drivers char fishing makefile. So here also needs the same. So $, big fishing pole. Okay. And then that's it. Okay. So installing modules, make modules install. Okay, so let's just do the make menu config and see what we get on our menu. And then let's see what happens. Okay, so let's go here. Okay. Now. Okay, so we're back to still. We're good still. So if I do make menu config. Okay. Go. Kconfig invalid option. Drivers char fishing kconfig. Let's go take a look at it. Drivers char fishing kconfig. What is it? Invalid option. Line 2? Tri-state. Why is that? Invalid option. You know what? Let's see here. Depends on fishing. I don't think we need all that. Drivers char fishing kconfig. You would add this line to driver's code and indicate where it's at. Our fishing pole module will look like this. If the fishing if you create a new subdirectory and want a new kconfig file to live there, you need to source it from an existing kconfig. You do this by adding a line such as the following. Okay. But oh, I have a feeling that this is actually there's more around this file. This is probably just assuming you add to the existing kconfig. I think we need like a header and a footer or something like how we saw in the normal kconfig file. So if we go to drivers char kconfig, you'll notice that the bottom here has end menu and here has menu. So I'm guessing we have to do the same thing. Let's see here. So it's gonna be menu, end menu. Okay, and then this one's gonna be menu fish master. Okay, let's see what happens, and then we can try it again. No. Invalid option. Why? Okay, so let's do something interesting here. Let's do olama ls. Okay, let's do an LLM. Let's have an LLM help us out here. I don't want Q80, I won't fit, so I'm going to just do olama pool llama 3.18b. Actually, let's go beyond our, we have so much RAM. You know what, let's do 5 4. Or actually, let's do DeepSeek R1. Let's do, is there like a 14B? Or let's go here. Models. There is a 14B, and which one is this one based off of? Quen, and then 32B is based off Quen. And let's do 14B. Maybe let's do 32B. Let's do 32B. So that one's like 20 gigs. We'll download real quick. 32B. DeepSeek. So now let's just let that one download, and let's ask the question. Let's see what happens. Okay, so I'm doing olama run now. So I'm actually running this. I think it should be both on GPU and RAM. So actually, let's just go and see olama ps. So yes, 69% on CPU, 31% on GPU. If I do NV top, I'll see that all my VRAM is taken up, but it's okay. So this is not a very good UI. So what should I do here? If I did Olama PS, it'll be forever. So let's just do this. Let's do source. No, let's do Python 3. Let's set up Open Web UI. So Python 3 m.bnb.env. So virtual environment, source.bnb, bin activate. Then let's do pip install Open Web UI. Uh-oh. What's going on here? Pip install upgrade pip. There's no Open Web UI? Is there a Docker container? Oops. Sorry, I'm like UI. Why is there? Get it. Let's get it. Pip install Open Web UI. Ensure you're using Python 3.11. What am I using? .13. Does that matter? It's okay. Let's just use that Docker container maybe. Let's see. Oh, too complicated. Really? No matching distribution found for what? Open Web UI. Let's just copy that. So Control C. Where are we? Okay. Let's do that. Different Python. Let's do this. We only support Python 3.11. Okay. You know what? I'm gonna go off. Actually, is it worth it? Let's learn how to set up a different version of Python. Let's do that. Let's set up Py environment. That allows us to run different versions of Python. I had no clue why I just exited, but I think it's called PyEnv. Simple Python version management. So let's do it. Linux, Unix, Linux. Let's just run this installer. And then we'll configure it. Okay, easy enough. Bye. Okay. Okay, so simple enough. Okay, so what do we need to do? Load PyEnv automatically by appending the following to bash rc pretty much. So this thing here. Okay, so Control Shift C. Okay, so I'm going to do bash rc. I'm going to do all the way down here. Boom. Okay, now what? Restart your shell for the changes to take effect. Okay. Are changes in effect? Load PyEnv virtual automatically by adding the following to bash rc. Load PyEnv. Okay. Okay. Now what? I should probably get rid of the virtual environment. I'm gonna recreate it. Okay, now what? Restart your shell for the path changes to take effect. Install Python build dependencies. How do we do that before attempting to install a new Python version? Oh geez, do we really need all this? I think I should assume we have all this, right? But let's just do it again. We already have all this, but I think we have OpenSSL too. But zlib, xz, and tk, I would assume we have it too. But let's just do it. So we need this stuff here. Okay. I guess we need a tk. All right. So now what? Okay, so we have our dependencies. And then we also need to set up a shell environment. Didn't we do this already? Oh, geez. We already did this. Okay, so usage. This is how we install it. Pipe env install 3.10. Oh, that looks easy. Okay, fine. Let's do it. What's the latest version of Python 3.11? I guess the docs will show us. So what, Python? Getting started, quick start. No. Quick start with Docker. I want Python. It's easier. It's easier. UV. No, I use PyEnv. Okay, so Py 11 to 3.11. Okay, let's do 3.11 then. So what's the command? PyEnv install 3.11. Okay, so PyEnv install 3.11. Okay. Oh, automatically does the latest one for us, so that's okay. And then what do we do to use it? PyEnv global 3.11. Okay, so let's do that so we can switch. Okay, so it's installing. Wow. Why is it taking so long? It's just Python. Okay. Let me pause. Okay, for some reason that took a long time, but that's fine. Now next, PyEnv global 3.11. So PyEnv global 3.11. So if I do Python 3, oh cool, that works. So what I can do now is create a virtual environment again. And then I can install OpenWebUI. Let's see. Pip install OpenWebUI. Nice. Okay. So then if we did this, wow. That's a lot of stuff. Oh yeah, I forgot. The reason why it would be slow is because this is a 6-core CPU. It's not that fast too. It's like a little over 2 gigahertz. New computer would help. You know, it's already starting to break down on me anyway, so. Good bandwidth though, I mean. Okay, it's installing all the CUDA stuff for whatever reason. This will be like underwhelming if I did all this and then it didn't work. That would be horrible. Okay, I'm just gonna pause and come back. Okay, so now I can just do open web UI serve, and it's gonna do a lot of stuff, but start up the server. So now we'll have a pretty GUI to do stuff. Oh geez, this is downloading models. Okay, what's going on? All right. So now, okay, it's probably just still gone. Okay, actually, I think it is working. So if I did localhost 8080, I think that's where it's at. Okay, yeah, cool. So if I do get started, I'll enter my name. Say Roger. I don't know. Roger at average dev. Not valid. Oh, average dev.dev. Okay. I think I might regret that. But anyway, so now it automatically detected my Olama instance. So if I just did hi, it'll probably then be able to respond. Yeah, hello, how can I assist you today? Okay, so yeah, it's slow because I don't have a good GPU. It's using mostly CPU inferencing, but it'll do. So what we need is we just need to copy this and give it a prompt. So I am trying to add a configuration option to my. Okay, let's do this. I am developing a simple Linux kernel 2.6 module. I am trying to add a configure option to my kernel module, but I am getting an error when I try to do make menu config. Here is the kconfig file living in the directory of my kernel module. It is in drivers char phishing. Then we can just do something like this, and then we can paste that, and then that. Okay, and I have also sourced the file in drivers. What do you say? Drivers char kconfig as source drivers char phishing kconfig. Okay. My error is, and let's just get the error. This is practice, right? Was it drivers char phishing invalid option? I'm just getting invalid option. So, oops. My error is invalid option on line 2. Let's do that. Okay, so it's a reasoning model. It's going to use Quen as like a base, so it's going to start thinking. So I'm going to let that just go for a bit and then come back. Okay, after like 5 minutes, literally, it's starting to think. And this is the pace of it thinking. So it's moving. Not the fastest thing in the world, but we'll leave it. We'll leave it cook. So let's see what happens. Okay. So it generated something, and now it called me out because I'm being dumb again. Ah, oh. I actually ended up typing with quotes right here, or no, I didn't. Wait a second. Oh yes, so I had to use plain quotes, plain double quotes instead of curly quotes. So this one right here was the mistake, right here. So I just straight up copied and pasted, and I should have seen it. These are not the right quotes. It should be like this. And then I think, yeah, let's keep reading. So the issue in your kconfig file is related to formatting and syntax requirements specific to the Linux kernel configuration. So yeah, anyway, use double quotes instead of curly quotes. Ensure proper indentation. Yeah, we did. Uh, okay, so key changes. Added tabs before each line under the configuration option. Module name clarification. Change phishing KO to phishing poll.ko. Why? We did call it phishing KO. Oh, it is because it's an LLM. It's not real. Okay, so anyway, this is additional tips. I'm pretty sure we got it right. Still processing, but I think this will fix it. So yeah, let's try to do the make menu config thing again. Okay. Oh, see, there we go. Where would we find our stuff? Would it be in? Would it be in device drivers? Character drivers? Where would it be? That's a good question. Let's see here. Multifunction? No. Where would it be? Generic drivers? No. Block devices. Oh, so I guess I'm looking for character devices. That's what I'm looking for. Character devices right here. So we should see our phishing stuff. Somewhere? Fishmaster, that's us. So we go here, Fishmaster 3000 support, new. Cool. So we can say, okay, let's compile as a module, and we can just do select, exit, and then we exit. It's going to ask for us to save the file. Do you want to save your new kernel configuration? I don't want to. So yeah, cool. We were able to add something to the menu. Thank you, DeepSeek R132 billion parameter. Very slow, but you caught a mistake I otherwise wouldn't have caught because I just straight up copy and pasted. Cool. Let's continue. All right. Okay, module parameters. The Linux kernel provides a simple framework enabling drivers to declare parameters that the user can specify on either boot or module load, and then have these parameters exposed in your driver as global variables. These module parameters also show up in sysfs, see later in this chapter. Consequently, creating and managing module parameters that can be specified in a myriad of convenient ways is trivial. Defining a module parameter is done via the macro module param. Okay, so this will be in our kernel module. Name type perm. Okay, here name is the name of both the parameter exposed to the user and the variable holding the parameter inside your module. Oh, okay. The type argument holds the parameter's data type, so it could be byte short, u short, int, u long, long, u long, charpy, character pointer, I guess, bool, or inv bool. These types are respectively a byte, a short integer, an unsigned short integer, an unsigned integer, a long integer, an unsigned long integer, a pointer to a character, a boolean, and a boolean whose value is inverted from what the user specifies. That is confusing, okay? The byte type is stored in a single char, and the boolean types are stored in variables of type int. The rest are stored in the corresponding primitive C types. Okay. Okay. Finally, the perm argument specifies the permissions of the corresponding file in sysfs. The permissions can be specified in the usual octal format, for example 0644, owner can read and write, group can read, everyone else can read, or by ORing together the usual SIFU defines. For example, SIRUGO, SIWUSR. Basically, everyone can read. User can also write. Okay? A value of 0 disables the sysfs entry altogether. The macro does not declare the variable for you. You must do that before using the macro. Therefore, the typical use might resemble basically module parameter static int allow live bait equals to 1, and then you declare this as a module parameter. Okay? Interesting how this really matters on the permission. All right. This would be in the outermost scope of your module source file. So at like the part where we did the module init and the module exit thing. In other words, allow live bait is global to the file. It is possible to have the internal variable named differently than the external parameter. This is accomplished via module param name. Okay. So sure. So that we could map the name of the variable to the real name that's declared out on the file. So here name is the externally viewable parameter name, and variable is the name of the internal global variable. For example, static unsigned int max test. So max test is here, and this is the one that we want to alias, maximum line test with the module param name. Okay. So normally you would use a type of char p, character pointer, to define a module parameter that takes a string. The kernel copies a string provided by the user into memory and points your variable to a string. For example, static char, pointed to a character name, module param pointed to a character's name called name, and then the type here is pointed to a character, no permissions. So if so desired, it is also possible to have the kernel copy the string directly into a kernel or into a character array that you supply. This is done via module param string. Okay. Here name is Here name is the external parameter name string. Is the internal variable name. Length is the size of the buffer named by string, or some smaller size, but that does not make much sense. Okay. And perm is a sysfs permissions, or 0 to disable a sysfs entry altogether. Oh, I'm starting to put this together. Okay, so there's going to be like a file under sysfs that will control the parameters or like the arguments to your kernel module. So you can modify and pass arguments in through by modifying these sysfs files. Okay, cool. All right, so static char species bufflen module param strings specifies species bufflen. Okay. You can accept a comma separated list of parameters stored in a C array via module param array. Cool. Okay. Here, name again is the external parameter, and internal variable name type is the data type, and perm is a sysfs permissions. The new argument num_p is a pointer to an integer in which the kernel stores the number of entries stored into the array. Note that the array pointed to by name must be statically allocated. Okay, so this one has to be statically allocated. You cannot use dynamic allocation. The kernel determines the array size at compile time and ensures that it does not cause an overrun. The use is simple. For example, static int fish max fish, so that's statically allocated array with max fish entries. The number of fish is going to be the number that we have. So okay, so we'll just do module param array with this fish array. It's a type int, the number of fish, and permission 0444. You can name the internal array something different than the external parameter with module param array named. So right here, feels like, why would we want to do that? I'm not sure. So the parameters are identical to the other macros. Finally, you can document your parameters by using module parm disk. Okay, so right here, the size is going to be the size in inches of the fishing pole. All these macros require the inclusion of Linux module.h. Okay. How much we have? Let's see. Oh, oh, let's just finish this module section. Okay. Exported symbols. When modules are loaded, they are dynamically linked into the kernel. Okay, we know that now. As with user space, dynamically linked binaries can call only into external functions explicitly exported for use. In the kernel, this is handled via special directives called export symbol and export symbol GPL. Exported functions are available for use by modules. Functions not exported cannot be invoked from modules. The linking and invoking rules are much more stringent for modules than code in the core kernel image. Core code can call any non-static interface in the kernel because all core source files are linked into a single based image. Exported symbols, of course, must be non-static too. The set of exported kernel symbols are known as the exported kernel interfaces. Exporting a symbol is easy. After the function is declared, it is usually followed by an export symbol, for example. So this is how you want to export a specific function to be called. So you define your function and then you use export symbol with the function pointer, or I guess the name of it. Presuming that the getPirateBeardColor function is also declared in an accessible header file, any module can now access it. Okay. Some developers want their interfaces accessible to only GPL compliant modules. The kernel linker enforces this restriction through the use of the module license directive. If you want the previous function accessible to only modules that labeled themselves as GPL licensed, use this instead. Export symbol GPL. Oh, cool. Wow. Okay. If your code is configurable as a module, you must ensure that when compiled as a module, all interfaces that it uses are exported. Otherwise, linking errors and a broken module result. Okay. I guess we'll continue next time. It's actually 47 minutes in already, so thanks.